Okay, so today we'll be looking at the first topic in P191, which is called units and measurements, or sometimes we can just refer to it as measurement, units, and metric prefixes. So this is going to give us a background, the backbone of your medical physics. Whatever you're going to take from today onwards is going to depend on your knowledge on these units and measurements, or we can include metric prefixes, although they are included in just those two words. So focus on what we call physical quantities. We'll talk about SI units, the metric prefixes themselves, but also we're going to conclude with the unit conversions. Then we'll look at some tutorial questions that I've included from your past papers so that we can be up to date with today's knowledge. So, to begin with, ladies and gentlemen, I'm sure we know to say these days we live in a scientific world such that almost each and everything is supposed to be measured. Whether you are conducting an experiment in a lab, whether you are a doctor, you are in a ward round, whether you are an engineer on site, you are going to notice that we are always making measurements. It's either you are making a measurement of how long something is. It's either you are a doctor and you're taking a measurement of how hot a human body is. It's either you are in a lab, you're a scientist and you are measuring how much ingredient or how much of a specific chemical you're supposed to put in your experiment for purposes of your accuracy. So what do we call those things that we are able to measure? Those measurable physical characteristics that we are able to measure. Those are the things that we term as the physical quantities. So if we say, or if you are asked what is a physical quantity, you can just describe it as any property that can be measured and expressed using a number and a unit. Those are the things that we term physical quantities. You're going to notice that you'll be measuring things such as length, which means length qualifies to be called a physical quantity. You're a doctor, you're measuring temperature of the human body. That means temperature is qualifying to be called a physical quantity. It's either you're measuring the mass of substance in a lab. That means the mass of that particular substance is um, qualifying to be called a physical quantity. Why? It's because one, it can be measured. Two, it can be expressed in terms of a number and a unit of measurement for different purposes. It might be for the purposes of accuracy, for the purposes of data analysis, for the purposes of communication. Because even if you're communicating with your friend, you write to say, okay, I've measured 2 kilograms. Then you just pass the information to your friend. Even someone who didn't attend that particular experiment, they're going to understand, okay, what is existing in this particular beaker is 2 kilograms of sulfur, such things. So these physical quantities are very important in our day-to-day living. Almost everywhere in the world, you're going to be applying what we call physical quantities, but also taking measurement. And it's the reason we are calling today's topic as the measurements, units, but also metric prefixes. So we've already given some examples of measurements that you can talk about, or physical quantities that you can talk about. You can talk about length. You can talk about mass. You can talk about temperature. You can talk about time. You're measuring time. We use time every day. Those are some of the examples of what we call physical quantities. Now, physical quantities are divided into two different categories. There is what we call base quantities, base or fundamental physical quantities, but also what we call derived or secondary physical quantities. I'll just write it like that. Okay, so these are the two types of physical quantities. There's what we call base or fundamental physical quantities, or sometimes we can also refer to them as primary physical quantities, whilst there's also what we call derived or secondary physical quantities. So from this word base, I'm sure you can understand to say these are the most basic type of physical quantities that are in existence. Or sometimes we can just say they are the independent quantities which cannot be further divided into any kind of physical quantities, which means they are the primary physical quantities, and all the other physical quantities, all the other categories of physical quantities that are coming after the fundamental physical quantities are going to be called as derived physical quantities, which means they are coming from the derived physical or the base physical quantities. They are being derived from the fundamental, which are the most basic. They cannot be further divided into sub physical quantities because they just exist like that naturally. They are the most simple existing type of physical quantities, and there are actually 7 of them. There are 7 primary or fundamental physical quantities. I've included a diagram for that. These are what we call the base physical quantities. There's what we call mass, which is represented by the symbol M. There's what we call length, represented by this symbol L. Time, represented by T. Current, electric current. Sometimes they'll put electric current. It's one and the same thing, which is represented by capital I or higher case I. There's temperature, represented by T there. There's amount of substance, which is represented by N, but also luminous intensity. These are what we call the basic or fundamental physical quantities. So there are 7 in total. You have 1, 2, 3, 4, 5, 6, and 7. These are the most basic types of physical quantities that you can measure, or that you can measure, or that you can take measurements of. Then everything that is derived from this using basic mathematics operations, it can be either by multiplication of the base physical quantities, or maybe addition of the base physical quantities, or division of the base physical quantities. All those quantities that are going to come after you've performed these mathematical operations are what we term as derived physical quantities. For example, those who know what area is, to say when you are trying to calculate the area, if maybe I have this rectangle here, then I say this is my length and this is my width or breadth, whatever you can call it. In order for me to calculate the area of this breadth, I'm going to say area is equal to what? Area is equal to length multiplied by breadth, which means I'm multiplying two physical quantities. I'm multiplying length by length multiplied by length. And this is going to give me what? This is going to give me length squared. So by multiplying these two primary physical quantities, which is length in this case, we've multiplied length to itself. We're getting length squared, thereby coming up with what we call area. That means area is a derived physical quantity, or a secondary physical quantity, because it is not naturally existing. It can be further divided into length and length, two independent lengths. So I've also included a table of some basic, or rather secondary physical quantities. We have length, we have volume, we have speed, velocity, acceleration, force, energy, density, moment, power, work, momentum, and pressure. These are some of the derived physical quantities. Of course, we can't mention all of them. As we are speaking right now, some more are being discovered. They are coming up with some more derived physical quantities by the combination of these things. All those new formulas that people are coming up with, all those new physical quantities, they are going to come from the 7 naturally occurring physical quantities that we call the fundamental physical quantities. So that is also another table just to show you what some derived physical quantities are. Okay, so one thing that you're also going to notice, ladies and gentlemen, in our definition of what a physical quantity is, we say a physical quantity is something that can be measured. And what happens after being measured, you're going to notice that it is going to be expressed in terms of a number, but also a unit of measurement. So it can be expressed in terms of a number, which is going to carry a specific magnitude, but also a unit of measurement. So what do you think is a unit of measurement? What do you think is a unit of measurement? Just a question, a general question. Whatever I can say is correct. What do you think is a unit of measurement in general? I know you know what it is when you look at it to say, okay, this is a unit of measurement. You can give numerous examples of units of measurement, but what is the unit of measurement in a or I can just say in simple terms? How can you describe it? Okay, so we can just say it is a standard that is used for definite magnitude. It is also used for measuring of a physical quantity. It's just a standard of measurement that is going to give you a definite magnitude. That is what we call a unit of measurement. So for example, if I'm measuring mass, I'm supposed to apply the unit of measurement for mass. And today we're going to talk about what we call SI units of measurement, which is the international system of units of measurement, which is the internationally accepted system of measurement, such that wherever you go around across the world, they are going to be using this as the standard units of measurement for easy communication. Because before the SI unit of measurement, or the SI system of measurement was discovered, there were some other systems of measurements that were being used, but they were so limited to specific areas. So for the purpose of global communication and global understanding, they came up with what we call the international system of measurement. So I've also included this in the tables that I've indicated. There are also two types of units of measurement. It's what we call fundamental units of measurements, but also derived units of measurement. So the fundamental units of measurements are the units of measurements that are used to measure or to quantify the physical quantities or the fundamental quantities. So if you look at this table of physical quantities, I've also included the SI units of measurements here. We have mass, which is measured using what we call the kilogram with the symbol kg there. We have length, which is measured using the SI unit meter. We have time, which is measured using the SI unit second, current, ampere, temperature, Kelvin, some amount of substance, mole, but also luminous intensity, candela. So these are the SI units of measurement, the internationally accepted system of measurement, such that when you use these everywhere you go in the world, someone is going to understand to say, okay, they were talking about this. There were other systems of measurements that were in existence. That, for example, if you go to the US, the United States of America, you're going to find that they measure mass using pounds. But if you just say, okay, this thing is worth or is weighing 50 pounds in Zambia, someone will be confused and they'll somehow need a phone to start making conversions. They start Googling how much is that in kilogram. But when you mention kilogram, everyone is going to understand because it's the standard international system of measurement unit that is used for the measurement of mass. Sometimes you find that they're using units of measurement such as feet for length, 6 feet tall, such things. But length, the SI unit for length is what is the meter. So those are the SI units of measurement. Then when it comes to derived physical quantities, it is also the same. For derived physical quantities, we also use derived units of measurement. You have the meter squared, which shows that you've multiplied two lengths. If the SI unit of measurement for length is meter, and for you to come up with area, multiplying length multiplied by length, that means you're going to get the meter squared for the unit of measurement of area. The same thing applies to all the other derived physical quantities. We are using derived units of measurement. For derived quantities, we're going to be using the derived units of measurements, which we have included in these boxes or in this column that I have here. Is there anyone with a question? Anyone with a question? All right, so if there's no question, there are now some other cases that I would love to talk about. You're going to find that when taking a measurement, you have a number that is too large or a number that is too small. For example, they've just asked you to say, you should, or if you want to document this number. How are you going to document that particular number? Or sometimes maybe you are documenting a number that is too small. Maybe I can say 0, like this. A number which is small like this. Okay. All right. These two numbers, you can see to say we have this number which is very big, but we also have this number which is very small, like this. So how do you document such numbers, or how do you handle such numbers in physics or in science? Anyone who has an idea, how do we handle such numbers when a number is very big or too small? How do we handle such numbers when it comes to physics or to science in general? Because you're also going to learn about the same things in chemistry. How do we deal with such numbers? Anyone with an idea? Okay, so
So I'm going to start on the first one.
okay, yes.
For for example, for this nine, don't know the number, but we can put as 90, and then we count the zeros ahead of the 90. Then we put that
Okay.
as the
All right,
uh,
very good. I get what you're saying. Yes. So in short, what he's saying is this is where we bring in what we call metric prefixes. This is where we bring in what we call metric prefixes. So what is a metric prefix? A metric prefix is just a word that's, or maybe instead of using a word, we can just say a symbol that is added to a unit to indicate a power of 10. I'm sure that is what our colleague was trying to mention here. So it is a symbol. Let me write it here. A symbol added to a unit. To a unit to indicate a power of 10. A power of 10 like this. So to handle numbers that are very big or numbers that are too small, that's why we bring in the knowledge of what we call metric prefixes. So from the standard units of measurements that we've talked about, maybe we've talked about a meter. Can give an example of a meter. I don't know who will be able to see when I use green. Okay, a meter like this. We are going to add a word in front of the meter, and that word is just going to mean to indicate a power of 10. That is why we bring in a unit of measurement. So if this number that I've written here was, we had the unit of measurement, which is meters here. Even here we have a unit of measurement that we that is meters to this small number that we have here. We are going to use metric prefixes to indicate a power of 10 to this unit of measurement that we have here, which is basically a meter as a base unit. So we have a table. And how do we apply metric prefixes? We count zeros, just as our friend has already specified. We're going to say multiply it by 10 like this. Then we're going to count the number of zeros. Like, for example, in this case, we know to say there's a zero, there's a point at this particular juncture. Then on this number here, we have a point here. We have a point at the end of this whole number, whilst here we have a point at that particular point also. So what are we going to do? We're going to count the zeros that we have here, starting from where our point is. So if we are going to the left, that means our power is going to be positive. Whilst if we are going to the right like that, that means our power is going to be what? Is going to be negative, showing that that particular number is too small. So from here, if I start from here, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means we're going to write this number as what? We're going to say this number is 9.0 times 10 to the power 13 meters, showing how big this particular number is using just a prefix. Instead of us writing this such big number that we have here, we've handled it in simple terms using metric prefixes. It is going to be called 9.0 times 10 to the power 13. Then the same thing is going to happen to this small number that we have here. Here we're going to count the zeros from this particular point here to the right. And we're going to say we have how many zeros? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so this is going to be 2.0 times 10 to the power minus 14, showing that this number is small by 14 zeros. 0.14 zeros before the 2. So it's just showing how small this number is. Instead of us writing this is your number, that we can simply use what we call metric prefixes to express those particular numbers. So there are some standard metric prefixes. I've included a table here, some common prefixes that are used with SI units. We have the base unit here. It can be a meter, it can be a second, it can be Kelvin. Yeah. And some prefixes that are going to be indicated. So if we have a giga indicated in front of a base unit, that means you have times 10 to the power 9. If you have a mega, that means you're talking about it times 10 to the power 6. If you have a kilo, that means you're talking about it times 10 to the power 3. If you have hecto, that means you have a 10 to the power 2. If you have a deca, that means you have 10 to the power 1. Like this, which means you're just multiplying it by 10. Then you have a base unit here, which is just a unit, a unit itself. If it's a meter, that means you have 1 meter. If it's a second, that means you have 1 second. If it's a Kelvin, that means you have 1 Kelvin. That is where we have our base unit here. Then when it starts to get small, we're going to do the same. We have deci, which means times 10 to the power -1. We have centi, which means times 10 to the power -2. We have midi, which represents times 10 to the power -3. And we have micro, which is times 10 to the power -6, but we also have nano, which represents times 10 to the power -9, with the number of zeros that we have here on the middle. So these are what we call metric prefixes. Very simple to handle. I'm sure you talk about, we use this language every day. No, gigabytes, megabytes, kilobytes. It's just showing you how big a byte is, or a bit, I don't know how you call it, based on the metric prefixes, simplified way of handling huge or very small numbers. That is that, ladies and gentlemen, when it comes to metric prefixes. So now I would love to talk about the unity conversions. And for us to start converting units, we're supposed to have a very good knowledge of these metric prefixes that we have here, because mostly the questions that you're going to encounter under unit conversions, they're going to be testing your knowledge on the metric prefixes. So we can go to what we call unity conversions. Okay, unity conversions like that. So what do we mean when we say unit conversion? It's just a process where you're going to be changing a quantity from one unit to another without changing its value, which means you're maintaining the same value, but you're just changing one unit from one unit of measurement to another. So mostly that's why I was saying to say you are supposed to have quite a very good knowledge on the metric prefixes, because you cannot converting mass to length. You're converting between the same unit of measurement. If your conversion is dealing with mass, it should be consistent with mass. If you are dealing with length, it should be consistent with length. If you are dealing with time, it should be consistent with time. But you are converting from maybe a giga to a milli. You are converting from a mega to a centi. You are converting from a kilo to a deci. But it's within the same unit of measurement. If it's a meter, that means it's the meter because you're dealing with length. If it's the kg, that means you'll be dealing with conversions from the kg to mega, giga, hecto, deca, such things. But just being consistent with one physical quantity. Okay, so Okay, so for us to understand more about unit conversions, I'm sure this is where we can just go direct into looking at examples, because you can understand this more by looking at an example. How can you convert from one unit of measurement to another without changing the actual meaning of that magnitude? If it is 5 kg, for example, wherever you convert it to, it should remain 5 kg when you bring it back to this. You shouldn't change the magnitude of, or you shouldn't change the meaning of the initial unit of measurement that you've been given. So let's look at some examples. Okay, I have these examples, and these questions, I just didn't get them from the blues. I got them from your past paper, your previous past papers, so that we can just also get familiar with how they'll be bringing your questions like that. Okay, so we have this question which is saying, with reference to length, convert the following. So you can already tell to say we are being consistent with length here. With reference to length, convert the following. 65 meters to millimeters. 65 meters to millimeters. Okay, so how do we convert 65 meters? 65 meters to millimeters. We're going to use what we call a conversion factor. We're going to use what we call a conversion factor between the meter and the millimeter. We're going to use a conversion factor between the meter and the millimeter. So how can you describe a conversion factor? It is a ratio between the two units of conversion, or the two units of measurements that you're dealing with, but it is a ratio that is going to give us, or which is going to be equal to 1. It is not going to change the meaning of the initial unit of measurement. It is going to be a ratio which is equal to 1 between the two units of measurements that you're dealing with. For example, you're going to say, how many meters or how many millimeters do I have in a meter? That means this ratio that we're going to get from here is what we are calling a conversion factor between a meter and a millimeter. So we just apply conversion factors when converting units from one unit of measurement to another. So from here, who can tell us the conversion factor? 65 meters. I'm going to multiply this with a ratio that is going to be equal to 1 between these two guys that we have here. Who can tell us the conversion factor between these two?
Did 100.
Sorry. Sorry. Who can tell us the conversion factor? How many millimeters are in 1 meter? Yes, go ahead. So I mentioned to say the only knowledge you're supposed to have, it's the knowledge about the metric prefixes. This is a meter. And how much is or what is this same value when you convert it to millimeters? You can go back. Where is that table? Previous. Okay. Milli here. When you talk about milli, that means you're talking about 10 to the power minus 3. What does that mean? That means 1 meter, which is the base unit that we have here, is equal to what? Is equal to 1,000 millimeters. So this is the conversion factor between a meter and a millimeter. So this is what we're going to apply in this question here. So we're going to say 1 or 1,000 millimeters over 1 meter. You are supposed to make sure to say the unit that you're trying to get rid of. For example, this meter that you have here, if it's a numerator, the way it is here, in the conversion factor, it should be a denominator. Why? It's because that's the only way you're going to cancel it out. The m and the m are going to divide, they're going to cancel out, then you're going to remain with 65 multiplied by the 1,000 millimeters that we have here. The meter that we're trying to get rid of has already been cancelled out. So you multiply 65 by 1,000, what answer are you going to get? You're going to get 65,000 millimeters. And you've converted the 65 meters into millimeters. As simple as that. The same applies when you try to convert question 2 here, which is saying 28 millimeters to centimeters. We're going to apply the same basic knowledge. We're going to say 28 millimeters. We're trying to convert it into centimeters. We should now look for a conversion factor between the centimeter and the millimeter. So I'll say my 28 millimeter here, which is a numerator. The millimeter is a numerator, which means when multiplying with my conversion factor, the millimeter here should be a denominator. Why? It's because I want the millimeter to cancel out with that one so that I remain with it, my desired unit of measurement as the numerator there. So 1 centimeter is equal to 10 millimeters, like that. 10 millimeters. So since the millimeter is already cancelled out, that means we're now remaining with 28 multiplied by 1 centimeter. What are we going to remain with? We're going to remain with 28 centimeters divided by 10, like this. And this is going to give us how much? This is going to give us 2.8 centimeters. That means you've successfully converted from 28 millimeters into its equivalent when it comes to centimeters. The same thing is going to apply 3 meters to feet. Okay, so this is what I was talking about, to say most people, when you just mention it in Zambia, because we're not very familiar with the feet, we use meters. But you can convert using the conversion factor between the meter and the feet. So we're going to say 3 meters. You're trying to convert this into feet. What is the conversion factor? We're going to say the meter there multiplied by, we're going to have the meter there and the feet there, because we are looking to cancel out the meter that we have there. So how many meters give us 1 feet, or how many feet give us one meter? Anyone with an idea? I know this is so random. Even in an exam, if they were to ask you about this one, they should give you a conversion factor at the end, because this is not very common. So 1 meter is actually equal to 3.28 feet. 3.28. Okay, so the meter and the meter has already cancelled out, which means we're just going to multiply 3 multiplied by 3.28 feet. And at the end of the day, what answer are we going to get? We're going to get 9.84 feet. 9.84 feet. That means you've successfully converted from your 3 meter to its equivalent in feet. Okay, anyone with a question here? Okay, so I was just explaining about this conversion factor. I was explaining to say it is not very common. So mostly when you are asked such questions, they are going to give you this specific conversion factor, because they understand to say you can't just gun this or swatter this from nowhere. It has to be provided with, or it has to be provided for somewhere else. So 1 meter is equal to 3.28 feet. It's just a conversion factor between the meter and the feet. So we multiplied that to get this particular answer. Then now we can continue with these other conversions. I made sure I added enough examples. So we have this one which is saying convert 38 kilometers per hour to meters per second. Convert 38 kilometers per hour to meters per second. Yes, Eunice, what is your question?
Yeah, on the example of just sorry to take you back. Is there another formula we can use to convert the question?
I don't understand. What do you mean another formula? Because I've said for us to convert, we need to use a conversion factor. So what kind of formula? I don't understand. Kindly help me with that.
Like, is there a different one apart from this one?
No, you're supposed to apply this specific formula.
Okay, thank you.
Yes, because mostly when you say is there a different way, that means you just mean maybe swapping the two, or swapping what you have in the conversion factor. Maybe this one becomes smaller, or this one becomes bigger, like that. So like when you're trying to convert, this is the way, or this is the approach that you're supposed to use. You're supposed to use a conversion factor. But sometimes you're just going to find that when maybe you're converting maybe if meters into millimeters, we said 1 meter. 1 meter is equal to 1000 millimeters, like this. So you're going to notice that instead of them writing the conversion factor like this, to say 1 meter over 1000, okay, we are converting from meter, which means we're supposed to put meter down. So instead of them writing 1000 millimeters like this, being equal to 1 meter, they're going to swap the two. They're going to use those prefixes that we talked about. They're going to say, they're going to say 1 millimeter. They're going to say 1 millimeter is equal to what? Is equal to 10 to the power minus 3 meters. This is the only way you can change here, but there's no other way around that you can use to run away from using the conversion factor. That is not possible. Of which I also find this method a bit complicating, because you're supposed to start using the metric prefixes. If you just make sure with the power here, instead of putting a negative, you put a positive. That means wherever you're going, it's soup. It's too much salt in the soup. Everything will be wrong. So I prefer just use this one. The one which is bigger, you keep it like this. 1 meter is equal to, the smaller one should be the one which will be in a large quantity, other than using the metric prefixes like this. But you just have to be very much familiar with the 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 different measurements between the two units that you are using. I hope that has answered your question.
All right. Yes, thank you very much.
All right, you're welcome. So let's proceed to the one we're looking at. So if you notice, this one we're only talking about converting one thing. We're just converting 65 meters to millimeters. Here we're just converting 28 millimeters to centimeters. Now, what about it when it's carrying two different things? Like here we have 38 kilometers per hour to meters per second. So this is also very simple, because the only thing we're supposed to do is use two independent conversion factors for each. We are converting the kilometer, but also the hour into meters and the second, respectively, which means we're supposed to use the conversion factor between the kilometer and the meter, but also the conversion factor between the hour and the second. As simple as that. So I'll say my 38, we know to say this is kilometer over hour. It's per hour, which means you are dividing an hour here. So 38 kilometers over an hour. It's 1 hour here. They just don't indicate it because it's 1 per hour, which means per 1 hour. I'm going to multiply this by the conversion factor between the kilometer and the meter. So which unit am I trying to get rid of? I'm trying to get rid of this kilometer that we have here, which means on my conversion factor, it's going to be a denominator like that. So how many kilometers or how many meters make up 1 kilometer? 1 kilometer is equal to 1,000 meters. This kilometer and that kilometer are going to cancel out. Then I'm also going to multiply this same equation with the conversion factor between an hour and a second. So what is the conversion factor? We're trying to get rid of the hour here, which means here it is a denominator. We're going to put it here as a numerator because I want it to cancel out. So 1 hour is equal to how many seconds? It's equal to 3,600 seconds. Like this. This is very simple. I'm sure you can convert to say how many minutes do we have in an hour? We have 60 minutes. How many seconds do we have in a minute? We have 60 seconds. So if you multiply 60 by 60, you're going to get this basic conversion factor. So we cancel out this hour with this hour that we have here. We are done with the units that we don't want. We've remained with the meter that we're looking for, but also the second that we're looking for here. So I'll say 38 multiplied by 1,000 here. We're going to get 38,000 meters over. Here we have 1 multiplied by 1 multiplied by 3,600 or 3,600. So we're going to have 3,600 seconds. This is what we're going to remain with. And if I plug this into my calculator, what answer are we going to get? 38,000. This is 38,000, not 3,000. 38,000 multiplied divided by 3,600. What answer are we going to get? What answer are we going to get there? Anyone who can give it a try?
Sorry, is it 38 or 36?
It's 38.
It's 10.5 or 1.05.
10 point what?
5. 1.055.
1.055. Anyone else who is getting this same answer? What answer are you getting? Anyone who is getting a different answer from her?
10.5, sir.
10.5. Okay, so someone is getting 10.5. Anyone
Oh,
else?
okay, yeah.
But you need to be careful.
Yeah, it's 10.
All right, so most people are getting 10.5, but it's not just a 5, there's a 6, I'm sure, after a 5. This is the meters per second. This is going to be meters per second. So we've successfully converted from kilometer per hour to the meter per second that they asked us to do without changing the actual meaning of this. If you convert it back to that, you should still be able to get the 38 kilometers per hour that they're looking for. Then we can also look at this one. We can also look at what is 30 cubic centimeters in cubic kilometers. What is 30 cubic centimeters in cubic kilometers? Okay, so this is now conversions involving volume. And what is the only different thing here? It's this power that we have here. This power that we have here is the only thing that is different in this particular case. So what do we do when you have been given such a question? You apply the same simple rules that we've been talking about. You'll say 30 cubic centimeters here and multiply them by a conversion factor. And this conversion factor should be a conversion factor between the centimeter and the kilometer. So since we're trying to get rid of the centimeter, of course, it should be down here, whilst the kilometer should be up here. So how many kilometers give, or how many centimeters give us 1 kilometer? How many kilometers give us 1 centimeter? Anyone who has an idea how many centimeters give us 1 kilometer? Guys, this is basic concept. This is a very simple question. We're just trying to get the conversion factor. How many centimeters will give us a single kilometer? And all you're supposed to do is the basic math. Okay, 1 kilometer contains 1,000 meters, and 1 meter contains 100 centimeters. Just do the conversions there and give me the direct value for the number of centimeters that are present in 1 kilometer. Anyone? Okay, someone has given us an answer. 10. What is this? Is it 100,000? Okay, 100,000.
I think it's supposed to be 100,000.
100,000, okay. Anyone else with a different answer? Okay, so I'll put 100,000 here. But sometimes if you don't want to put 100,000, you can just say 10 to the power 5. That's why we were talking about the metric prefixes. If you want, you can just say 10 to the power 5. That means you're still talking about 100,000. So this is the simple form of a conversion factor that that is giving us the conversion between the kilometer and the centimeter. So what are you supposed to do now to this conversion factor? You're just going to apply brackets there and do what? And also raise it to the power 3. Make it cubed. That means you are done with this question. Wherever you go after this, you're going to come up with the same thing, because this is the same now as we're going to distribute this. I have power 3 there. Even here, I'm going to have power 3 here. That means it's the same as I'm having 30 centimeters or cubic centimeters multiplied by what do I have at the top here? I have 1 kilometer to the power 3 and the kilometer to the power 3, like that. So 1 kilometer to the power 3 is still 1 kilometer. So I'm going to have 1 kilometer to the power 3, because this one, which is on the unit of measurement, is going to remain the power 3 over I have this one now at the bottom. So if I have 10 like this, 10 to the power 5 like this, then I have centimeter. Where's my eraser? I have my centimeter there. Let me say I have 10 to the power 5, then I also have my centimeter there. Then I raise this to the power 3. It's the same as I have 10 to the power 5, this raised to the power 3, whilst the centimeter is also being raised to the power 3. Like that. Are we together? If you don't want, that means you can just write the 100,000 as you wanted here to say 100,000 like this to the power 3. Then centimeter here to the power 3. It's one and the same thing. So I'll put it here. 10 to the power 5. Then you have to the power 3 there. Then you have centimeter to the power 3. After this, you can see to say the centimeter to the power 3 will cancel out with this centimeter to the power 3. That means you've gotten rid or you've gotten rid of the units that you don't need. We are only remaining with the desired units. Then from there, you're going to say 30 multiplied by a kilometer to the power 3. We'll have 30 cubic kilometers over 10 power 5 multiplied by 3, or you can multiply the powers there. What answer are we going to get? 100,000 to the power 3. It will be 10 to the power 15. 10 to the power 15, like that. So you're just dividing 30 divided by the power 10 to the power 15. You just multiply the powers here. This is basic indices, rules of indices. It's the reason when you are doing this topic, you have to bring back that knowledge on indices, the same things from grade 10. They still apply here. And we'll keep on looking at them even as we dive to dimensional analysis. You are supposed to remember your knowledge on indices. If you have 10, for example, to the power 3 multiplied by 5 here, that means you're just supposed to multiply these powers. If you have a to the power 10 divided by a to the power 9, that basically means 10, or that basically means a to the power 10 minus 9. These are the things you're supposed to remember. So just basic indices, you should be okay. Okay, so divide 30 over 10 to the power 15. What answer are we going to get? Okay, so we're going to get 3.0 times 10 to the power minus 14 cubic kilometers, and that is going to be the answer. 3.0 times 10 to the power minus 14 cubic kilometers. That means we are successfully converted from the cubic centimeters to the cubic kilometers without changing the actual meaning of the given value. Okay, we can look at one more example on unit conversion. We'll never talk about unit conversion like this again until you have a tutorial sheet. That's why I just want to make sure we are done with it. So 55 square meters like this to square millimeters. So we're going to do the same. We're going to apply the conversion factor between a meter and a millimeter, and we just said 1 meter is equal to 1000 millimeters, like this. Then what do we do to this conversion factor? Since the initial unit of measurement is raised to a square, to a power 2, we're also going to raise this to a power 2, like this. That means we're going to have 55 square meters being multiplied to 1000 power 2 millimeters power 2. That means we're going to have a power 2 there, but also a power 2 on the unit of measurement. The same here, power 2 on the one here, even power 2 on the unit of measurement. So I'm going to have 1000 squared, millimeter squared, over meter squared here, since 1 squared is still the same as 1 squared. This meter will cancel out with this meter that we have here. That means I'm remaining with 55 multiplied by 1000 to the power 2 square millimeters. If I plug that into my calculator, I'm getting an answer which is equal to 55 million. Okay. 55 million. That's a lot, isn't it? Okay, 55 million square meters or square millimeters. The final answer is 55 million square millimeters, like this. Of which, if we write this into using metric prefixes, it's going to be what? 55.0 multiplied by 10 to the power what? What will be the power here? Since we have 6 zeros, 1, 2, 3, 4, 5, 6 times 10 to the power 6 square millimeters. That will be our final answer. And that means we are done with this particular question. So we've looked at how to convert when you have two distinct units of measurement in one measurement. We've looked at how to convert when the unit of measurement is raised to the power 3. We've also looked at how to convert when the unit of measurement is raised to the power 2. We've also looked at how to convert when the unit of measurement is just in a general form like this. Then let's look at one final example, which is saying the floor of a room is 4 meters by 5 meters. The floor of a room is 4 meters by 5 meters. How many 80 centimeters by 60 centimeters tiles are required to tile the floor of this room? How many 80 centimeters by 60 centimeter tiles are required to tile the floor of this particular room? Okay, so they've given us the dimensions of this room to say it's 4 by 5 meters, 4 meters by 5 meters. So which means the first thing we can do is what? Is find the area of this room. Then after finding the area of this room, we should convert these units of measurements that they've used on tiles to meters again, since the meter is the SI unit of measurement for length. We should convert these units of measurement to meters again. Then we should also find the area of each tile. Then we can divide the area of the room by the area of a tile to find how many tiles are going to be required to tile this room. So this question has just been asked in a scenario way to test your knowledge if you've really understood. So we're going to say area of the room, I'll put area of the room here, will be equal to 4 multiplied by 5 meters. 4 meters multiplied by 5 meters. And this is going to give us how much? This is going to give us 20 square meters. So if 20 square meters is the area of the room, let's find the area of one tile by first converting the 60 centimeters into meters, but also the 80 centimeters into meters. So we know to say 1 meter is equal to 100 centimeters, which means we're just going to divide these numbers that we have here by 100. Even this one by 100, that means we have 0.6 meters here and 0.8 meters there. So let's now calculate the area of each tile. We're going to say 0.8 meters multiplied by 0.6 meters. And the area of each tile will be equal to 0.8 multiplied by 0.6. What's the answer? Okay, this is going to give us 0.48 square meters. Okay, so if this is the area of each tile, how many tiles are going to be required to fill up 20 square meters of the floor that has been given in the room? So we're just going to divide this 20, which is the area of the floor, divided by the area of the tile to find how many tiles are required. So we're going to say the number of tiles, let me use red, the number of tiles will be equal to the area of the floor over the area of the tile, of each tile, which is going to be equal to 20 square meters divided by 0.48 square meters. The square meter and the square meter is going to cancel out. We have 20 divided by 0.48. This is going to give you 41.66 tiles. But since this is, or since we need a general number, this is asking about the actual number. We're going to round off this number that we found here. So since it's 41.6, if the number that is immediate after the point is above 5 or is above 4, that means we're going to write it as what? As 42 tiles. 42 tiles are required to fill up this floor, which is 4 meters by 5 meters in dimensions. So after reaching that point, ladies and gentlemen, we have concluded what I had prepared for us for today. I just wanted us to have a brief introduction to P191, look at physical quantities, what they are, units of measurement, metric prefixes, but also conversion of units. This is just a simple introduction to P192. And unless anyone has a question, anyone with a question? Anyone with a question? Anyone with a question so that we go back and explain quickly?
Okay, so I need you to go back to question. This one that was a 30 centimeter cubed and the other one 55. You were a little bit fast. I did not grasp the concept here. I don't know if you can help me understand.
All right. Okay, so I said here the concept is as simple as converting the between units that are the normal units, the basic units, these ones that we have here. It's the same. It's just that we are supposed to raise our conversion factor to that particular power that has been specified in the initial measurement. So, for example, if we have 30 cubic centimeters to 30 cubic to cubic kilometers, 30 cubic centimeters to cubic kilometers, what are we supposed to do? We are converting volume. This is volume. So what are we going to do? We're going to apply the same conversion factor of a centimeter to a kilometer. And we've said we're going to say 30 cubic centimeters here multiplied by the conversion factor between a centimeter and a kilometer. So since we want to get rid of the centimeter, here it is supposed to be on the opposite side, which is a denominator. Okay, so how many centimeters are making up 1 kilometer? That is the question that I had asked. And we said 1 kilometer consists of 10 to the power 5 centimeters. That's what we said, right?
Yes.
Yes, we said 1 kilometer has 10 to the power 5 meters or 100,000 centimeters. Okay, so this is the normal conversion factor between a kilometer and a centimeter. So what are you going to do to this one? We have a power here. So we are going to put this same power, we're going to apply this same power to the whole conversion factor here. And when you distribute this power, we're going to notice that we're going to have 30 cubic centimeters like this multiplied to, we're going to have, if I distribute it on the numerator here, I'm going to have 1 to the power 3 kilometer to the power 3 like this, over, if I distribute it to the 100,000, I'm also going to get 10 to the power 3 or to the power 5 like that, raised to the power 3, and the centimeter also raised to the power 3. That means I've distributed this power that I have here. And from here, we can already see to say this centimeter, cubic centimeter can cancel out with the cubic centimeter that we have there in the denominator. That means you've gotten rid of the unit of measurement that you don't want, which is in this case the cubic centimeter. And from here, what are you going to do? You can tell to say 1 raised to any power, it is still 1. So here we only have 1 there, and a kilometer to the power 3. So that means, in short, what expression are we remaining with? We've remained with 30. We've remained with 30. We've cancelled out this cubic centimeter multiplied by the cubic kilometer here, which is 1 cubic kilometer like that, over this guy that we have here, which is 10 to the power 5 raised to the power 3, of which I explained to say using basic rules of indices. When you have such a scenario where you have a number raised to a power, then brackets to another power is the same as you are multiplying these two powers. So it's just the same as you have 10 to the power 5 multiplied by 3, which is to the power 15. So you can divide 30 over 10 to the power 15, and that's how you're going to get your answer. But you already have your desired unit of measurement, which is the cubic kilometer there. So anyone who can give us the final answer? Thirty divided by 10 to the power 15, what will be the final answer?
3.0 times 10 to the power negative 14.
3.0 times 10 to the power minus 14 cubic kilometers. That is going to be your final answer. And you've successfully converted from the cubic centimeter that we have here to our cubic kilometer. That is the desired unit of measurement here. And you're just going to get this same concept and apply it to this particular question. The only difference is that here we're using a cubic, here we're using a square. So instead of raising our conversion factor to a power 3, in this case, we're going to raise it to a power 2. I hope that has helped.
Yes, very much.
All right, thank you very much. Any other question?